Started around 2015. I've been looking for a way to normalize data. That's one of the fundamental tasks when you start a software project. You want to design your tables, basically your data containers, so that they don't change much. They're designed in a way that they can catch all the data that you throw at it. And the common problem that I've seen in the systems that I've worked on is that it doesn't happen that way. The structure changes through time, and the structure changes a lot. Sometimes the CEO just wakes up one morning and he realizes, oh, I need something like this. I want this to be changed this way, and so on. So that's a huge pita, a huge headache whenever that happens. And so yeah, and in that exploration, I think around 2018, I had this old structure wherein I had the data structure that was able to store data, but still I encountered difficulties because I based it on the file system, the Windows file system, the file system on your desktop, right? And I realized that it's still restricted, right? And not everything can just be put inside a folder or in a directory. And then that's when I started wondering, how can we do it? How can we humans do it? How is it that we are able to reorganize our thoughts, or reacquaint or redefine our thoughts very easily every time something changes and something comes up. And that's when I had the same feeling. I think it's very similar to what you're describing. Our data is so scattered in so many platforms and so many communities and so many apps. And one of the questions that I found, and I think the answers that I came up with for the questions, was that there were so many designers behind the scenes. There's a team of designers in Australia, team of designer in Philippines, team of designer in India, in the US, and everyone is doing their own thing in their own teams, right? And the structures that they come up with are not inherently compatible. They're not inherently ready for integration. So that's when I started looking into neuroscience, and then I've encountered this concept called grandmother cell. And basically, it's a hypothesis that what we're doing with neurons is just combining ideas with one another. So let's say you have an idea for mother, you have an idea for old, and you have an idea for caring or something. And then you combine those ideas and you have grandmother. So but then each person will have his own definition of that grandmother, because some grandmothers are stubborn, some grandmothers cook very good food, and some grandmothers are like sleeping and so on. So we have different definitions. So that's how the project came about, because in my search for the data structure, I then found that. And in one of the meetups, I think it's the free software Melbourne, um, I, I was able to share in one of the presentations that you can actually represent coding structures and data structures using biological neural networks. So this is different from the popular neural networks in AI and deep learning. So I'm just simulating biological neural networks, their structures as well as their behavior. Unfortunately, during that time, I think the prototype was very basic. It didn't have that web-based tool that I shared in the previous sessions. But I think now is the time that we might be able to take advantage of this new language that might be able to help us. Yeah. Yeah. So, so I was actually in a call the other day with uh, Jay Singh. He was in the same meeting as us in the mixer. You weren't there. Mengru was there. The Mengru was there.
Cool.
Yeah, and I was talking to him about how we might use neurUL to support his project. And I mean, and I think that can really help him, because he's working on an incident management application. And what that will do is like, it's Asana, it's like Asana, or the with Planner or DevOps. Are you familiar with like tracking tools in software? Like you track issues and then you track them to closure. Yeah.
Yeah.
So the only difference is that, in addition to viewing the data on a platform, on a user interface that you described earlier, that's specific to a user group, um, what we can do is users or special or admin users or special users can go straight behind the scenes in the neural network and add their own comments or likes in on any part of the data. So that's one of the things that we can support. So let's say, like in Facebook, right? You cannot like a like in Facebook, because the fact is that that idea is not supported or wasn't supported by the developers and the designers when they were working on Facebook. Like, why would you like a like? But in reality, that is something that you can really do, right? And think of, right? You can say, let's say, for example, this girl likes this TV, and I can really like the fact that she likes that TV, right? But our software doesn't support that. But how is it that we can think of that, right? So that's what um, neurul might allow you. So let's say, for example, you proceed with you decide that you would like to create apps using neurul in the background. Then those apps can then do that. And as I mentioned, I think in previous sessions, in Catalyzer, we also support, the platform also supports container technology. So you can run it in your own desktop, or in your server at home, or in the cloud. So it can, I think, based on what you described is your goal, I think I can really help you with the technological part, the technical part in supporting. I think all that we'll need now is just the user interfaces, the platforms or the perspectives, as I'd like to think of them. So some users will not have to deal with the neural networks. They'll just have to deal with the basic UI, but behind the scenes, it's powered by this neural network, which can accept any data structure.
Mm, sounds good. Yes, because in the
Yeah.
next, so in sounds actually excellent. You're far ahead
Mhm.
of what I told you so far, because the next
Mhm.
step would have been that, instead of having just rigid structures, what data can be uploaded, right? That basically anyone can upload any data, it will be stored, and anyone can access that data and gets it translated into the form that they want to, that they need it to use it, right?
Exactly. Yes. Yes. Yes.
Cool.
Definitely. And at the moment, whenever I have a to-do note, I'm like, where do I post it? Where do I save it? There are so many platforms, and the problem is, whenever I post it in a specific platform, it's stuck there. It's
Yeah.
stuck there. And it's not like how we think, right? We think of something, we remember something, and then later, maybe after sleeping, when we wake up, that's the time that we associate it, or maybe in a dream we associate it. But before that, we don't associate information, we don't structure information immediately, right? Sometimes it takes time, like a week or even a month, for us to structure information. So yeah.
Yeah, and when I remember that right, the information in our brains is stored in a native way, in a big cluster, in an unstructured storage, and then we access that data by putting some structure on top of it, right? And only
afterwards
and afterwards,
Afterwards.
and
Yeah, yeah.
and only the data that we have attached the structure to is the one that we feel that we can access, and everything else is just randomly popping up whenever we
Yeah,
want it. We don't want it to.
exactly. So yeah, I think I can. I would be happy to support. The vision that you have there, because I think it's really in line with the vision I had as well, and I definitely feel that we can work on that. Yeah. Mhm.
Cool. That's amazing, because I think
Mhm.
that I and Mengru, we were probably capable of helping you with your user testing.
So this is the neural network. This is the Dash Neural Studio, right? Um, and I'll just show you how it's structured. I should have opened it before, just a second. So um, it's like a Facebook Messenger. You can think of it on the left side as a Facebook Messenger, or WhatsApp Messenger, where you're able to just post neurons or ideas at any time, right? But in addition to posting random thoughts or random messages, so you can have your own account, for example, and then you will see that the messages on the right or the neurons on the right are your neurons, and the neurons here on the left are the neurons posted by other users. In addition to just using it as a messenger application, you can also use it to create data structures. So in this case, buy milk. Now you can see that buy milk uh, defines itself as an instantiation of a message, right? And at the same time, it's also an instantiation of a task. So right there, you will see immediately that this is one of the main differences from a typical messenger application. I just drag our faces to the left. So if, for example, I reload this, it will show you here a new type of sentence. So that's why it is a universal language, because our hypothesis in this project is that the biological neural network is actually a language. It's code. And you can immediately see here what I mean by that. So by milk, this neuron here instantiates a message. And what is instantiates message? Instantiates message is just a combination of the ideas instantiates and message. And then instantiates by milk is also instantiates task. And what is instantiates task? It's also instantiates and a combination of task. Now, what is a task? A task is something that has a status, right? And what is a message? A message is something that has a sender and a receiver. So if you reload this, just pardon me because I still need to fix this so it appears at the center always. It keeps on showing up at the end. So buy milk uh, is a message. Yep. Right. Instantiates a task. A task has a status. Right. And then buy milk has a status of in progress. So you can see here, buy milk has a status of in progress. And what is has status of in progress? Uh, yeah. So here immediately you can see the relationships coming up. So buy milk has status of progress. It is indeed a task because it has a status. So that's a common thing between buy milk, which is this one, and a task. It has a status, right? So this whole structure here, as you can see, is already a sentence or a paragraph of information. And what it means is that maybe it's not bad that we started with words and sentences and noises with using our mouths, but this is the high fidelity version of information. And this was mentioned recently in the interview between Joe Rogan and Elon Musk, wherein maybe there's a way of communicating information that doesn't lose the fidelity of information, because what's happening is we have memories in our brain, and in order for me to be able to communicate those memories, I need to convert that into this channel, verbal channel, which is highly limited. It's two-dimensional, or one-dimensional. But in fact, all information in our heads is structured this way. And what we do is we just combine this information, and it's flexible. It's ultra flexible. So then, if, for example, we're thinking about community posts in your perspective or app, then any idea can just connect to startup, let's say to a startup neuron, and then immediately you will see all the records linked to startup. It's like hashtagging, but on steroids.
Yes, I'm.
Yeah,
Believe it or not, I'm 100% with you. 100% with you.
amazing. That's great. That's great.
I'm just saying it.
Yeah,
That's what's in my head, which I can't really formalize, find words for to explain it to people.
that's great. I'm so relieved to hear that, because it really takes time for me to explain the project, and it's very rare for me to find people who are just out of the box. They're just getting it like that. Yeah.
Yeah, that's pretty cool. Love it.
Yeah, so this is the main problem, in programming. We create classes, we create records, we create tables, and whenever there's a structural change, it just gives us headaches because we have to change everything on top of it, the UI, the APIs, and so on. But doing it this way, if it's not supported by the UI, the user can just go straight in here and add a comment for buy milk,